Hello, everyone. Welcome to this joint SimScale and Valispace webinar. My name is Ioannis. I'm a solution engineer with SimScale, and together with kind guys from Valispace, Antonio and Paul, we'll be presenting a simple AI and CFD workflow for electric vehicle battery pack cooling design. So maybe a few words from Antonio and Paul before we start.
Hi, so I'm Antonio Soares, again, solution manager here at Valispace. My background is in mechanical engineering. I was actually a CFD consultant before joining Valispace, and I've been here for over 3 years now. Paul?
Hello, everyone. My name is Paul. I'm a customer success engineer here at Valispace. My background is in microelectronics engineering, and I've been with Valispace for 2 years now, and I'm excited to take part in this webinar.
Thank you, guys. So let's get started then. Let's go through the slides, and of course, there's a live demo that will follow. So the agenda for today is we do a short intro for SimScale and Valispace, and then we go directly into the SimScale Valispace workflow example of, in this case, we've used the battery pack cooling design to demonstrate how SimScale and Valispace can work together to automate your simulations within your process management system. Then after the live demo and showing you the workflow, there's going to be a Q&A session where all of your questions can be answered. Feel free, there is a chat box. You can already start typing in your questions, and we'll handle them right at the end of the session. So now let's start with a short intro of SimScale. So SimScale is a simulation company headquartered in Munich, Germany, but also having offices in the US. Generally, we support more than 500,000 users worldwide, and we have customers in more than 50 countries right now. We get almost 10K new users per month joining our platform, either academic or commercial users, and we support many academic institutions worldwide. Right now, we promote remote working because we also promote remote simulation, right? So we are more than 130 employees spread across 8+ different time zones in the world. So how engineers can benefit from SimScale and what powers SimScale, right, within the simulation industry, right? So we have customers all over the industry fields, spanning from electrification, energy, automation, new space, and net zero cities. So we support all of these major trends right now, but also traditional engineering simulation firms doing standard FEA, CFD in the conventional way. All of them rely on the power of SimScale in the cloud. And you can already see a couple of logos listed down here of a couple of our customers. Now, what are basically the differentiators of SimScale? SimScale is a simulation platform entirely based on the cloud. It's not only cloud-based, but it's cloud-native, and that basically means that SimScale was already built from scratch to work in the cloud, right? It's not a tool that started on-premise and then transitioned to the cloud. It started right away from the cloud, so it's cloud-native and entirely based on the cloud. So you can access SimScale from anywhere by just opening your browser and typing simscale.com. You can access all of your simulation projects. Within SimScale, you can find different physics. So we are a multi-physics platform supporting both fluid flow, thermal, structural, and electromagnetic simulations under the same graphical user interface. So you don't have to switch a single window, you can do it all. Since we are on the cloud, you can log in, you can invite your colleagues, logging in, and you can collaborate in a Google Doc style of collaboration. You can easily just invite people, work together with you on projects, quickly share your projects with other, even customers with a click of a button, and generally access your projects from anywhere, from your office, from home, while traveling, while being at a conference, right? You can just log in and access your projects and demonstrate them live to your customers and colleagues. Furthermore, we have lately introduced AI capabilities So you can basically just use all the data you have simulated in the past, or even just create new simulation data in SimScale and train your own AI models. And this will basically help you in the future if you are doing repetitive work on similar geometry, similar models, right? You can train your own AI model seamlessly using your simulation data that's already available in the cloud and get results within seconds. Finally, since we are in the cloud, you are not blocked by hardware, by the on-premise requirement for hardware. You can access with a click of a button unlimited computational resources, simulating with up to 192 core machines in the cloud. Any scale, right? You can run parallel jobs, right? And you don't have to wait for days for those to be completed. Instead, you can run them all in parallel and get results within few hours. Now, a quick example here of multi-physics. Here we see an electric motor, and we just added here a couple of screenshots and animations that show you how from a single component, which is this electric motor, you can get all different types of simulations, starting from CFD analysis of the cooling channel, just a quick thermal analysis on the casing of the motor, then a structural analysis of the shaft and the rotor itself, and then also an electromagnetic analysis of the electric rotor, right? So from one model, you can run multi-physics, and all of them, as you can see, in the same graphical user interface, in the same window, right? You can run all these different analyses. So what someone can do with SimScale right now, you can basically do, you can start right from the start, right, by importing your CAD model, modify your CAD model, prepare it for simulation. You can do the meshing, discretize it in smaller, in this control volumes to solve the mathematical equations through the PDE solvers, both CFD, FEA, electromagnetics. And then you can also train your own AI models if you want, using the data you've already simulated. And of course, final step, do the post-processing inside SimScale. And all of this is done purely on the cloud, right? So you can basically run a full CA process from the start to the end, right at the SimScale, and we'll see an example of that in a while. So with this quick intro to SimScale, I want to pass it to Antonio, who will do also a quick intro to Valispace.
Okay, thank you, everybody. So very quickly, hi. So Valispace, as the title says, is an AI-powered systems and requirements engineering platform made by engineers for engineers. So it was founded by a couple of aerospace engineers, Marco Witzman and Luis Lindblad, who were quite familiar with the challenges of complex hardware engineering and what is supposedly like a very futuristic industry, right? Which they found were still using very outdated methods. And so they saw, they experienced the cost of working in siloed environments and, spending a lot of their time managing documentation, in files for different tools and, working on their side of the project, and then coming to the conclusion that maybe they were working on outdated specs. And so this really slowed down, this really slows down development for engineers. And so they set about to create this tool based on, at least 3 pillars, 2 of which they sustain the product for most of its existence. And now with the advent of LLMs, they've been able to tackle the last one, which is the AI-assisted engineering. And so the premise of Valispace is in keeping all of this data that is typically spread out across documents and tools truly interconnected, and we'll see how in a bit, and to provide this tool that can be accessed by all stakeholders, not just the engineers, right? So a lot of engineering work is done in specialist tools, and only the specialists really have then access to the actual raw data. And then again, like with the rise of LLMs, all this interconnectivity that is already present in the tool is quickly leveraged into an AI-assisted workflow. So the first pillar, right, the connected data. So Valispace has what we call the values, which are essentially system variables. So any engineering value in Valispace, be it in a requirement, be it in your system design elements, these are properly parameterized and they can cross-reference each other. So that when you update, say, a property for the calculation of a mass in one component, it automatically updates that mass, and then that mass automatically updates, another mass up the component tree. And this is then all traced, right? At every level, who did the change and when, what it was before, what it is now, and you have a full history. So you can trace these design decisions. And they have an immediate impact. Once you do your change, once you do your iteration, it has an immediate impact on your design, and you can see if it's still in compliance or not. In terms of concurrent engineering, right? Again, so what you do affects what other people do, and what they do affects what you do, of course. And you can quickly communicate, you can quickly see changes that happen, and you can use these live engineering values not only for your calculations, but also for your reports, for your assessments. And so these things always live updates. So again, you can have specialists, and you should have specialists on the platform, but you can also have other project stakeholders who might not be specialists, and they can very quickly adopt the tool and get to use it and make it work for them to make the right decisions and make sure that you're building the right thing on time. And of course, one of the big aspects of the tool is that it also has an open API, right? So it's web-based like SimScale, and this is also then what allows us to interoperate with tools such as SimScale and push data back and forth without having to come up with some very complex or bespoke solutions, but just by using standard web technologies. Then, of course, since all of the project data is already interconnected and parameterized, this makes it, primed to be used by LLMs, right? So we've built our solution, of course, based on commercially available LLMs, but then we still have our service that makes use of the LLMs and properly structures the data for inputs and outputs. So instead of just copying, pasting stuff from one tool to the other, which was the problem to begin with, we now have a fluid workflow where you say, okay, I want to improve this requirement or this set of requirements with these parameters, within these parameters, and you get back a structured response that gets inserted back into your Valispace workflow. And we have clients, again, who've tried this out, and they say that this saves them a lot of time, be it generating initial sets of requirements to generating a whole project from scratch with some system design elements and engineering values. And so to kind of wrap this up, so for you MBSE enthusiasts, so we who are familiar with the V model, so Valispace came out of this inspiration from MBSE. The founders even coined the term DDSE back in 2018 or 2019. So data-driven systems engineering as a particular flavor of MBSE. And so Valispace helps you go through this V model, right? And specifying your requirements or design in a data-driven and connected approach, connecting it to your design, keeping those calculations within the tool or directly connected to those specialist tools like SimScale. And then these verifications of your design, which can be not only done at the end, but which can be continuous, right? As you have these parameterized requirements. And so as you are making a change, you are verifying if it's still in compliance or not. So with that, I will hand it back to you, Johannes.
Okay, thank you, Antonio. That was great. Okay, that was a great intro. Antonio, of course, I know everyone is waiting for this live demonstration that can see our tools in action. So let's not waste any more time. Let me walk you through one or two slides that explain the example project we were showing today. So imagine you are, of course, that's a simplified example we built here just to show you how it works. But imagine you are developing an electric vehicle, in this case, and here you're working in the battery system component, right, of your electric vehicle engineering team. So you can see a simplified schematic. The center we have in the battery pack, and then all the different components that can interact with the battery pack, which is apparently the motor of the vehicle, the cooling system of the battery pack, and then a subsystem for the pump and the heat exchanger that drives the cooling, and also other auxiliary systems like the radiators or air conditioning or any other system that can be connected to the battery, right? So that could be a very complex configuration of the whole vehicle, right? And you can build this totally inside Valispace, right? You can build this configuration management totally inside Valispace. Now, because you are working in the simulation team, you want to link simulations with this configuration system. And you can essentially apply engineering simulation to any of these subsystems we see here, like the pump, the heat exchanger, the motor itself, as we saw before. So let's see how can this be done in practice by focusing mainly on the battery pack. So let's say we got our battery pack here. Our main design goal is to determine a proper setup to avoid any overheating of the batteries during the different driving modes of the electric vehicle. And we might have different requirements that we need to fulfill. But let's say the main requirement we need to fulfill is the ensuring that we do not see temperatures higher than 40 degrees Celsius with a safety factor of 1.5 degrees. So 38.5 degrees would be our upper limit, right? So we don't want to see any such high temperature happening, because otherwise the design will not be good, right? Will not be ready for production. We need to do something to change the this behavior. So what can drive the heating of a battery, right? Can be many stuff, like maybe the driving mode of the car, right? Maybe increased power requirements from the AC system or other subsystems of the car. But today we assume that, okay, we want to increase the required power for the motor and see the effect of that requirement, the increased requirement, right, to the battery pack, right? So requiring more power, meaning that the batteries are working harder, right? So they emit more heat, and we want to see how we can tackle this larger heat generation. And the ways to tackle that would be change the cooling channel that we have on top of the cooling plate, right? Or change the liquid that runs through the cooling channels, change the composition of the liquid, change the flow rate, so pumping more liquid or lower liquid, right? Also taking into account the pressure drop happening. And also maybe another design variation we can do is changing the location, the placement of the battery cell, like maybe add more spacing between the batteries, or I don't know, change the configuration in general. So these are only some of the potential variations, okay? So let's go to see how this looks like in practice. So let me escape the slides right now. And just first go to SimScale and give you a quick intro on the platform. So we are here, as I told you, we are cloud-based. Just go to simscale.com. You can access SimScale, and you can log in with your account and see all of your different projects, right? So here you can see I got a couple of different projects of an exhaust manifold, another cooling application of a battery charger, some FEA analysis, all in the same platform. But today we are focusing on this battery pack cooling. So I'll just open it. And here I am inside the project where I uploaded the CAD files from my CAD tool. We support all of the major CADs. You can see a couple of different formats here. That all of them are mainly supported, also neutral format. So you just drag and drop your CAD file here in SimScale, and then it lands here in the geometry tree. So this is the battery pack with the cooling plates on top. You can see inside we have the cells, and you can create a new simulation using this CAD tool. I already did it here. So I have an existing design. That's, let's say, the baseline design that my engineering team has. That consists of a certain fluid, which is water glycol mixture 50%, then different solid materials here, aluminum for the plates, copper for the cells, etc. Of course, everything is customizable over here. The conductivity, specific heat densities of the material are customizable, so you can assign the material properties to any of the solids taking part in the simulation. And then other info that are important for the simulation are the boundary conditions, where here we have the velocity inlets of the cooling channels, where we pump in the water glycol mixture at a certain flow rate and a certain temperature. Everything you see here is editable and customizable. And then at the other side, we have the pressure outlets. And of course, we have the external walls of the battery pack itself that is in touch with the ambient environment and has a 30 degrees Celsius temperature because it lies in the battery compartment. It's kind of hotter than it should normally be at the plain air outside. So everything you see here can be customized through the API. So we can basically link any of these quantities you see here via Python and pass it to Valispace. So Valispace can basically read all of the information shown here. Now, once you are happy with the setup, you can run a new simulation. And you can see here, this is already simulated. It took me like 2 hours to simulate it in the cloud. And I can post-process the results, or I can also save results and look at them quicker. Like every time I log in, I can click the save results here, and I can take a look and also download them and also pass them to Valispace. So now the goal is, okay, what if I change something, right? What if I change the heat source of the batteries, which is defined here with a power source? What if I make these batteries emit more heat? Instead of 12 watts, they emit more. So let's now go to Valispace and see how it works. Same as SimScale, I'll just go here to Valispace. And here at the main screen, the first thing I want to look at is the requirements. So I have created a requirement set for the battery and the cooling system. I can see all of the different requirements here. And the main requirements are listed on top, the ones I want to use SimScale for. Just I tag them here to make it easier for us to see. So the main requirement is not exceed 38.5 degrees, but also not exceed 50 kilopascal of pressure drop in the cooling system, and also not exceed an average temperature of 30.5 degrees in all the batteries, right? So all of them are met right now. And for this demonstration, I'm really good to go. All of them are green. I have also other requirements. We can ignore them for this example, but you can see how Valispace has smartly generated other requirements for my system. Just to give you an example of how fast it is, we can easily just say, add a new component here. We can name it, for example, radiator. And we can ask the Vali assistant to generate automatically requirements for us based on the AI, right? And the other projects that done. So we can generate the requirements, and we can simply type a description, for example, radiator for an electric vehicle, for example. Okay, just a text or some description. We can continue. And this will automatically basically generate a couple of requirements for our system, right? You see? So automatically it told me, okay, the radiator shall have a minimum cooling capacity of 10,000 BTUs, cannot be higher than 150 Celsius, minimum surface area. So it gives me already a starting point, and I can, of course, add more requirements on top of that. I will skip it for now. And I will basically maybe remove it for this demonstration and go back here to my requirements. And again, take a look how the valleys are basically highlighted, right? So these are the valleys, Antonio, right? The ones that I can link with any tool, in this case, SimScale, and they are all interconnected with each other, right?
Exactly right. So valleys are always a part of something, in this case of requirements, right? And so again, yes, you can call them up through the API and send them off again to SimScale or wherever you need.
Okay, that's perfect. And it really helped me with this project. And I believe also our audience will find it really useful. So now let's go and see our system design, which is built here. We have the electric vehicle system. And then we have all these subsystems we discussed on the intro slides, the battery pack, the coolant system, and the drive motor. So let's say, for example, I want to check the material I'm using right now. I can see here that I'm using the 50% glycol water. I can anytime just switch to any of the materials. I can imagine I can have a list of infinite materials here and pick which material would be used. But in this case, I want to make a change to the system, and I want to basically go to the drive motor and say, okay, what happens if I increase the required power? So let's increase the power mode here and ask for like more power from the batteries. Okay, so I select the new power mode, and what I can easily now quickly do is go to the dashboard I've built and submit a new simulation to SimScale by clicking this button. So I have submitted now a new simulation, and if I go back to my project here, and I can, if I quickly refresh, you see a new branch has been created automatically, modeling the new configuration. And then a new simulation has also just started with the new data. So I've given now more power to the batteries. So I can see here, now it's 13 watts per battery, right? So this will run now a new simulation, and when the results are ready, will be automatically updated back to Valispace. Now, if I go back to Valispace and check the analysis here, this is the initial analysis report that was generated for my first battery configuration, which passes the tests, all green, right? All the 3 checks are passed. I can see a summary of the inputs and outputs. Here you can build it yourself. You can add anything you want. And also you can pull data from SimScale, like the residuals of the simulation, post-processing screenshots, etc. Right? So you can pull all the data here and have it as a quick check to say, okay, I'm good to go, or everything is green. Now, assuming that the simulation is already finished, we can pull the new data. I'll just use the quick algorithm now to just pull the new data. The simulation is not yet finished. Apparently, it needs around an hour to finish, but I'll just pull the data from a finished simulation. So once the simulation is actually finished, the data, you can see it's been updated here. The data will be automatically pulled and update my report. So the new simulation has, with increased power, has finished, and you can see basically new inputs, new outputs. You see the maximum temperature now is higher. Also, the average temperature is higher. Also, the plots are automatically populated. And you can see as a result, now the requirements are no longer met, right? So I have a temperature that's higher than the limit. Also, the average temperature is not respected. So now I can see as an engineer, okay, the change I made doesn't work. This won't be approved. I have to change something. So I can go back, consult my team, see what can I change. And maybe the first thing I can change is go here to the cooling system and increase the the flow rate. So instead of pumping 0.13 kilograms per second of glycol, I can double that, for example. So I can select the alternative. I can start a new simulation. Of course, you can even automate that. Every time you change something in Valispace, you can automatically run a new simulation without having to submit it manually. That's also an option, apparently, but it might be helpful to just check everything before you submit. So I submitted a new simulation. This will basically run a new simulation again in my SimScale project. And once the results are ready, I can see them being updated here. So after an hour again, the results will be ready. And when the simulation is over, Valispace will, SimScale will sell the data to Valispace, and the report will be updated again. Again, seeing my requirements turning green, because now, despite I have a higher input of heat, I have a higher flow rate. So this leads to dropping the maximum cell temperature and the average cell temperature, and keeping the pressure drop within the acceptable limits. And the report is updated. I can see the updated screenshots. And that's how it basically works. Now, you might ask, how is this achieved, right? We are connected to different tools. This is achieved through Python. And if I quickly show you here, through the scripting, we have here a script that basically drives all the communication between SimScale by importing all the packages related to SimScale, also importing all the Valispace packages, and by writing a script. Of course, if you choose to go with SimScale and Valispace, we can help you set it up for your first project and then have it there and just customize it. But you can see all of the scripting here, all of the parameters like velocity at the inlet, temperatures, everything is here via Python. And this script you see over here drives all the connection. Okay. Of course, this can be also done offline with your like local workstation. You can have the script and done it from your local workstation, but it can also be done directly here into the Valispace workspace. Okay, so this basically summarizes it. And if I am to quickly show a summary of the results. So we've seen how from the baseline design, where we have a certain input, a certain output, right, where all the requirements are met, maximum, minimum, average temperature, and pressure drop are met. By changing the drive motor mode to a higher power requirement, we see that we no longer meet the temperature, maximum and average temperature requirements, right? Then by doing another change, by increasing the flow rate into the cooling plates, cooling channels, by doubling that, we managed to meet the requirements and drop the temperature below the acceptable limits, right? So now the temperature is respected, but also despite the pressure drop rises because of the higher flow rate, it's still below the 500 kilopascal, which is the minimum, the maximum requirement for the pump. And if I am to summarize a couple of screenshots here of the model, those screenshots are generated through SimScale, and you can be saved and can also be transferred to Valispace or any other Python friendly tool, right, that can read create an API script, right, that can read this post-processing material from SimScale and pass it to anything. To conclude this demonstration, because we also talked about AI, how can AI generate quick requirements for you, for your systems through Valispace. AI can also be applied on the SimScale side. For example, imagine you have simulated hundreds of different battery packs in your company, and you want to use this data for training an AI model. You can basically use this data, and right within SimScale, you can train your models. For this case, I have a simple exhaust muffler, right? where we used it to train a model, just to give you an example, right? Where we basically parameterize the CAD model, different holes, different placements of the muffler, of the pipes, right? We've run 200 different simulations. Of course, if you are a muffler designer, you already have this data there of your different mufflers or whatever you are designing, pumps, fluid channels, cooling plates, right? You already have this data, but you can use this data and train the AI model inside SimScale. And basically, this is a CFD reference simulation. And then with a trained AI model, we can get almost 100% accuracy in the results by simply just training the model and feeding in a totally new unseen muffler design or any other model. We managed to get almost perfect accuracy with this model within few seconds instead of waiting few minutes or hours to simulate it. So that can be applied to any of your models, whether it is a CFD simulation, a muffler, or an FEA analysis. We can train your AI models by bringing in your data. Of course, that's just a quick teaser of the AI. We have dedicated webinars on AI. You can just quickly Google SimScale AI and you can see the available webinars that dive in more detail and more depth, right, in the AI capabilities. All right, with that, I would like to conclude the demonstration and the live webinar. Of course, we have now the Q&A session, and I will just like to hand it to my colleague Nachman, who can moderate this Q&A session and bring up any questions you might have, and are already in the chat. Also, feel free to start typing in your questions right now as well, if you haven't done it already.
Fantastic. Thank you so much, Ioannis and Antonio and Paul. Can you guys all hear me okay?
Yes.
Yeah, brilliant. Thank you guys for a super interesting presentation. There's definitely a lot of interest in this topic right now, and we're getting a lot of questions coming through as well. Several of you have asked about the recording for this webinar. Yes, it will be available. Just give us a couple of days to process the video, and we will share this with everyone. So if you registered for this webinar, you'll get an email to the video recording. Okay. Ioannis, why don't we start with some questions here? Let's take a step back, Ioannis. Tell me how SimScale works in terms of resources, right? So core hours. How does that actually work? And this example that you showed here today, what's a rough idea of kind of core hours this would have consumed?
That's a nice question, and that's something that most of the people are curious about. So SimScale is based on the cloud, and you have access to unlimited resources, right? So you can basically, every time you submit a new simulation, a new instance is dedicated for you in the cloud, and your simulation is handed there. So with SimScale, you can, if I quickly show you, you can basically go up to 192 core machines. We typically leave it to automatic, so SimScale will automatically decide based on the complexity of the model, of the size of the model, right, which machine is better for you. But you have the option to always bypass it and go up to 192 cores. Now, if you run multiple simulations in parallel, multiple instances are reserved for you. So you can, for example, run a design of experiments with starting in parallel 5 different flow rates for this example, right? All of them will be submitted in parallel, and if one takes 1 hour, then all of them will still take 1 hour. Now, how this works in reality is basically a finished simulation. You can see it over here, gives you the total time needed and total core hour consumed, right? So if this simulation was submitted to run on a 32 core machine, it could run for roughly 2 hours. It will consume roughly 64 to 70 core hours. This is how it works. So number of cores times the hours that it runs, and this is how the consumption works. When you go with SimScale, you have a pool of core hours based on the packets you choose, and every time you simulate something, these core hours are deducted from your pool of core hours, right? And this pool can be shared within your team, your company, right? So every time you run a simulation, you can see how much it consumed, and this is then deducted from your pool.
Nice, amazing. But Ioannis and Antonio and Paul, we have 2 or 3 questions. I'm going to cluster them together because they're around the same topic, which is the geometry and the CAD. Maybe Ioannis, you answer first, and then Antonio and Paul, from the Valispace perspective, you can answer as well. So first question is, how do you bring in the actual CAD model, right? What kind of formats of CAD models can be accepted into SimScale? And then specifically with the SimScale and Valispace workflow, in the workflow that you described, either now or in the near future, is it possible to also control the cooling plate geometry, for example, you know, the height, width, aspect ratio, and that also becomes a variable into the simulation process or the AI to help optimize? Thank you.
Yes. Okay. Also nice question. So as we saw, in SimScale, you just simply upload your model by clicking the plus button here. And we do support most of the formats out there, like 90%, 99% of the CAD tools out there are supported by SimScale. You can see a list here, but you can also learn more detailed description. And of course, you can manually just drag and drop it here. But if you are working with the API, you can basically just pull it from a folder, or even connect your tool. If it supports API connection, you can connect your tool directly to SimScale API, pull the CAD, and then connect SimScale to Valispace. Right? So I guess this also answers the question about the CAD modifications that you asked, Nachman. So you can easily parameterize the cooling plate or any other geometrical parameter, but this should be done through your CAD tool. So if you have your CAD tool working with API, for example, Python, you can ask for parametric conditions like maybe the diameter of the cooling pipe, or the height of the cooling channels, or whatever, the thickness of the cooling plate, or the configuration of the battery cells. And you can basically make this parameter directly available through Python, and also parameterize that and connect it to Valispace, as we did for the simulation parameters. So it just depends on your CAD tool and whether or not it supports. Yes.
And Paul and Antonio, is there something you want to add on CAD handling in Valispace and using that as a parameterized model?
Yeah, so Valispace does not handle CAD data, so we could hold a CAD file, but we wouldn't really manage it in terms of a parameter. So we do have one out-of-the-box integration for SolidWorks, which for now is limited to one way. So you can map your CAD parameters in your parts or assemblies to Valis in Valispace. So you can edit your CAD and say if you have like a recalculated mass or geometric parameters in your CAD model, those can be pushed directly into Valispace, and they in turn can then affect certain calculations that can feed into the initial and boundary conditions of a simulation in SimScale, for example. But like Ioannis was saying, yeah, the CAD work still needs to be done in the CAD tools, and then can be directly pushed to Valispace and SimScale.
And what kind of other cool projects are you working on in Valispace? This was an example of a battery pack. What other kind of products and components does Valispace lend itself to where you've seen it particularly successful?
So the platform itself is somewhat agnostic. So it's centered around hardware development. The founders were from the aerospace industry, and at a certain point we used to say we do everything from rockets and satellites to coffee roasters. We no longer have the coffee roaster client, but pretty much any aspect of hardware engineering, any industry. We're in automotive, we're in aerospace, we're now medical devices. As you know, we've recently been acquired by Altium, so there is a strong integration going with the electronic side of things. So really, if you can design it, Valispace will handle it.
Amazing. And we have a question actually, which brings us up nicely to perhaps a summary, Ioannis, of the whole of the whole webinar. How would you get started with this? If someone's watching this webinar now and wants to have a go at this workflow, SimScale and Valispace, how do you get started? Where would you start in SimScale? Would you start in Valispace? How would you go about getting access to both of these?
Yeah, so if you want to start, the first thing you want to do is maybe contact us and we can help you. You can start with any tool, depending on where you want to focus. If you want to focus on simulation, you can first start with SimScale and practice simulation and build your first simulation if you are a total beginner, for example. But you can also, if you're more interested in the system parameterization, system design, you can also start with Valispace and then decide to couple SimScale to Valispace. Anything works, depending on how you wanna see it. Just feel free you can contact us either SimScale or Valispace and express your interest, and we can help.
Okay, fantastic. That's all the questions we had today. Just an admin summary. So we will share a recording of this webinar. You can get in touch, like Oana said, directly here at valispace.com or simscale.com. And you can also talk to Oanis directly as well. Oanis from the SimScale side was involved in developing this workflow. So he's the expert from SimScale. Oanis, we actually had one attendee asking if you can share your email address. So maybe we can post that directly in follow-up email or on this chat function.
Yeah,
so from my side,
already
I'll
here.
wrap up.
Yep.
Yeah, there you go. It's at the bottom there. If you can zoom in there, where you see Johannes's picture. So just at the bottom there, his SimScale email address is there, and same for Antonio and Paul. So I'll wrap up the Q&A session and say thank you to the presenters, and I'll hand back to Johannes.
All right, thanks a lot, Ahmad. Thank you everyone for attending. You can check our contact data here at the bottom of the slide. And you can also contact directly, either join SimScale or valispace.com and request a demo if you would like to, or contact directly sales at SimScale. And within a few working days, one application engineer from either SimScale or Valispace will be with you and try to help you get started. So thanks for joining. Again, I'm Ioannis, a solution engineer. Feel free to reach out if you have any questions. And I'll just hand it quickly to Antonio or Paul if they want to add anything before we close the session.
Yes, I'd like to thank everybody who attended the webinar. Again, if you have any questions, please reach out. You can also check out our webpage at valispace.com. You can quickly do some story lane demos if you want to get a feel for the software, and of course, reach out to our experts or our sales team if you want to get a little bit in depth into your use case. Thank you, everyone.
Thank you, guys. Thanks for joining. Have a nice rest of the day.